So we've talked a bit about the inverse sine and the inverse cosine. Now let's look at the inverse tangent. Okay? If we consider one period of the tangent function between negative pi over 2 and pi over 2, right? So if we look at just one period of our tangent function, right? And we have these asymptotes, right? And notice that we're not saying less than or equal to, right? Then we have a one-to-one function because the graph passes the horizontal line test. Right? And recall the horizontal line test is one that says that, hey, if I can make a horizontal line and touch my function once and only once, then I'm considered one-to-one. For each x value, I have one and only one y value. Okay. The graph of the inverse tangent function looks like an elongated S. Right? So the graph of the inverse tangent function kind of looks like an elongated S, and importantly, right, these asymptotes that I have here based on my domain become asymptotes on my inverse tangent function based on my range, right? But this S curve, right, if you could picture an S that got stretched, that is your inverse tangent function. Okay? Now, because y1 equals tangent of x and y2 equals arctangent of x are inverse functions, right? Then the domain of one is the range of the other. So in other words, because the domain of the tangent is from negative pi over 2 to pi over 2, then the range of the arctangent is from negative pi over 2 and pi over 2. Right? That's what we're talking about here. That the domain, including these asymptotes, becomes the range, including those asymptotes. And as well, because the range of the tangent function is all real numbers, right, from negative infinity all the way to positive infinity, because the range of the tangent is all real numbers, then the domain of the arctangent, the inverse tangent, is all real numbers. Okay, so this saying everything from negative infinity to infinity. Right? Another way we could say that was with that fancy looking R, which is all real numbers. So, much like we did in our work for the inverse sine and the inverse cosine, it will be very helpful to think about what each expression represents. So what we're asked to do in this part is for each of the following, write the words that describe the concept conveyed by the expression, and then evaluate the expression. So for this one, we are asking, what is the tangent ratio of pi over 3? And the answer to the tangent ratio of pi over 3 is that it is the square root of 3 over 2 divided by 1/2, because that is the sine of pi over 3 divided by the cosine of pi over 3, which simply simplifies to be the square root of 3. Okay? Then the arctangent of negative 1. Give the answer in degrees and radians. Okay? The arctangent of negative 1, we could think of this as saying what angle has tangent ratio of negative 1. Right? Well, if we think about this, we know that our tangent ratio is positive 1 at 45 degrees, and it is negative 1 in that fourth quadrant. Right? So for my arctangent, Remember that the outputs are between negative pi over 2 and pi over 2. So what angle has a tangent ratio of negative 1? The answer to that would not be the second quadrant, where it is negative, but rather the fourth quadrant, such that I will be between negative pi over 2 and pi over 2. So the answer to that is negative 45 degrees, if I'm in degrees, or it is going to be negative pi over 4 if I am in radians. Okay? You can work through C and D as your own practice. Okay? Hopefully, if you are not understanding that, you're comfortable coming in to ask questions, right? But it is very important that you understand what these represents. That here, hey, I have an angle as my input, but with the inverse, I have an angle as my output. Okay? Make sure you get your practice in.